Hi, I'm Michael Strong, and I'm the principal investigator on this NSF-funded project to look at how agent-based modeling can explain math performance in the 8th grade. Over the years, I've been interested in looking at the effects of principally teaching on student outcomes. And what I know from educational research is that typically only one or a few variables are looked at one time. And we know that there are many different variables that have an impact on student learning. What makes this study potentially powerful is a combination of factors. First of all, we have access to a data warehouse rather than a database from a large school district that kept very rich data going back over 15 or so years and collected information more than the rudimentary student and teacher information.
So over time we captured, I think we're over 17 years of data at this point, over 3,500 different variables that describe students' experiences in our system.
What was interesting in the San Jose database was the question of what is a pathway of a student, through their years in a school. And if you look at the system from the point of view of that student traveling that journey, what does it look like? What affects that student?
What intrigued me about this project was that agent-based modeling has the ability to look at a number of different variables and their interactions.
In a traditional statistical model, you're estimating some parameters that summarize important relationships. In agent-based models, what you're trying to do is describe how individuals interact so that the variables you care about can emerge from that.
What made me interested in the possibility of using agent-based modeling was two or three different things. One was the ability to work with some people who were outside the field of education but had the ability to use this powerful tool to look at large data. Secondly, the ability to look at some questions that were a little bit more complex than even the most sophisticated statistical models.
I had developed a relationship with Los Alamos National Laboratories. And when I went to them first, they thought, well, we're not really involved in education. We're not qualified to be involved in education. And I said, do you have children? And everybody in the room said yes. And the next thing out of their mouths were, we're not really happy with their education. And I said, well, would you be willing to look at education as a phenomena?
Education is important to Los Alamos National Laboratory for three reasons. One of them is to build our workforce. Second reason we do education programs is because it's important to have an informed electorate. And the third reason we're involved in education is because we're a member of a community.
The National Laboratory does modeling of complex phenomena to help decision makers deal with very complex issues that affect people's lives. And that became the theme of how I could build a team of external partners and utilize the unique capability here at the National Lab. As the idea of the project began to form, the first step I took was to consult with our technical staff. I wanted to know if there was scientific merit. What is the worth of doing a model of education?
As a statistician, I looked at the problem and tried to determine what would be appropriate methodology to bring to bear here. Certainly there's been a lot of statistical analysis done on educational data, but what we were looking for was an approach that would go beyond the existing approaches and bring in the agent-based modeling approach, which I believe gives us a better way to handle the interactions between the different agents in the model.
Modeling is useful because if you're doing statistical analysis, you're basically working with the data that you have. You're building a statistical model, you're possibly forecasting the future, but agent-based model like the one that we're using enables you to really experiment with different, you can make up your own population of students with the characteristics that you want to use. You can test different scenarios. Early on we had a meeting in Austin where I basically just stood up at the whiteboard and we just brainstormed all the different things that could influence student performance and how they were related to each other. And there we ended up with, I think, 30 or 40 different things. And of course, then the challenge was to figure out, we can't just throw 30 or 40 different things right in the model. The challenge was to figure out how to make those into a few things that we could really do computation with.
So in trying to develop a model like this, you can think about it as being a framework, right? What are the gross level interactions that we care about? What are some of the primary variables that are going to drive that?
And the two most important ones are student ability and teacher effectiveness. But then we also looked at the influence of a student's peers in a classroom on their learning. And also for each year of the model, we went back 1 year and looked at the student's score from a previous year, because that gives you some idea where they're starting from. So we had those 4 factors, and then we had to figure out how to put them together mathematically, and that's the really tricky part. And so we ended up converging on something relatively straightforward, which is just a weighted average of these different factors.
We're the first college of education, to my knowledge, in the world that actually has an educational data visualization laboratory, which is in partnership with Texas Advanced Computing Center. And Texas Advanced Computing Center actually has one of the most advanced and largest visualization centers in the world.
The first thing we wanted to communicate was what an agent-based model is and how it works and how it differs from other statistical approaches. So we created an interactive animation that demonstrates that process.
It's been an interesting process of thinking about what we wanted to represent and what was special about this model and this project.
I think what the next stage will show us is whether we can run simulations that actually will address some of the issues that are burning issues for educational researchers and education practitioners.
Over time, what we'd like to do is use many more of the variables that are available to us. And this prototype model simply demonstrates the kind of proof of concept for this type of approach.
We see this as the initial step, and now we want to move towards more sophisticated and complex models.
This NSF project has generated so much energy within the laboratory. I see this as the beginning of an effort that will expand over many, many years and hopefully become a very large investment in solving a grand challenge, which I think if you go across the country, you talk to most people on the street and they're going to tell you, we want to improve the education system.